Welcome to Chapter 2, Series and Mathematical Induction. Our first topic for Chapter 2 is sequence. This is not the first time you've heard of sequence. You studied sequence in grade 9, arithmetic sequence and geometric sequence. So let us go back to sequence. It is a function whose domain is the set of natural numbers. And this is how we list the elements of a sequence. You're familiar with this. And so this means the list goes on to infinity. This is what you know. A sequence is a set, but it is an ordered set. Because ordinarily in a set, you can jumble the elements of a set and it is still the same set, but not with sequence. So there is an order into the elements of a sequence. Each of these, we call them the terms. The term of a sequence depends on its place, depends on its position in the list. For the moment, let us set this aside, okay, and let us go back to the definition. Because this is the first time after many weeks of studying conic sections that we are mentioning the word function. Your general mathematics is devoted exclusively, at least the first part of it is devoted exclusively to function. And it's kind of strange that we have never mentioned function in precalculus until this topic. So a sequence is a function whose domain is the set of natural numbers. Look at that. Pay attention to that. So its domain is the set of natural numbers. That means each of these elements, we are going to pair it with exactly one other element or one other object. But what is different about this sequence is it is not telling us what sort of objects are we going to pair with each of these natural number. That means this set can be any kind of set for as long as the pairing is a function. So what again is our understanding of a function? It is a pairing. You are matching the elements of your domain so that each of these elements would be paired to exactly one object in the range of your function. And for this sequence, we don't know yet the range. Since our definition of a sequence does not tell us what is the range, what kind of set it is, it means it does not have to be a set of numbers. It can be in fact a set of objects. And you saw this in abstract reasoning. So you saw this when you took IQ tests. Or maybe you see this in Facebook. There are puzzles there. So the first object is this one. So this one looks like the arrow of a compass. The second object is this one, the third, the fourth. And the challenge to you is, what is the next object? So you can look at this as a finite sequence. This is the first term, the second term, third term, fourth term. What is the fifth term? We also defined function as a set of ordered pairs. So where is the ordered pair here? Well, the matching. Each matching produces a pair. This is the natural number, number 1, and you are pairing it with a sub 1. We call this the first coordinate and the second coordinate. Again, let us pay attention to the definition. It is a function whose domain is the set of natural numbers. This is how we can look at it. Number 1 is the one in your set of natural numbers. You can look at it as a slot, an open slot, an empty slot. Number 2 is the second slot. Number 3 is the third slot. And what the function does, or what the sequence does, is it will put an object into each of these slots according to a rule. So in our example, in our first example, the rule is the set of even integers. So this is the first slot and the object that occupies it is 2. This is the second slot, and the object that occupies it is 4. In general, if this is the nth slot, the object that will occupy it is 2 times n. This is the set of ordered pairs that is there in your set of even integers. So let us bring back and let us review the terms that you will meet in sequence. So this is how you write or you list the elements of a sequence if it is an infinite sequence. Although you don't have to say it's an infinite sequence, you just call it sequence, and it means it is infinite. When your sequence is finite, you have to say explicitly that it is a finite sequence. Okay, the terms. What are the terms of your sequence? So these are the terms. The individual elements that is listed in the set, that is your terms. You also have the thing called the general term. Okay, you understood the general term as the formula. So in this case, the formula here is n squared plus 1. But then again, just like what I told you, the word formula applies to numbers. But the elements of a sequence does not have to be numbers. It can be objects. So we can look at the general term as the rule. The rule that will tell you the object to assign to a specific natural number. So in this case, our general term is a sub n is equal to n squared plus 1. Okay, so this is your sequence, and it's not always convenient to write it in this way. We pay special attention to notations, to convenient notations in math. That is something to always keep in your mind. We pay attention to convenient notations in mathematics. So instead of writing down the individual elements of a sequence, we can just write it in this way. So this one compact notation is equivalent to this. This is a sequence whose general term is defined by n squared plus 1.